So, hello everyone. I'm Romina Druta. I'm a senior cloud and security researcher in Visma. If you would have asked me 1 year ago if I'm going to speak publicly, I would have said no. But God is doing some things really strange, and my manager asked me to speak about this project outside my company, so here I am. Usually I forget to tell what I'm doing, so not to pass this time. I started as a test engineer, testing mobile applications. Then I become a software developer, and then going a little bit in the operations field. So I can say that I was in the all DevOps lifecycle. So I'm working for Visma. For those of you who do not know what Visma is, what they are doing, we are a top 5 software company and #1 in cloud ERP in Europe. We have a wide network of distributors and partners, and we are operating across Europe and Latin America. What I love in Visma is that we have a large and diversified technology stack. We are not forced to use only one type of tool. We are analyzing those tools, and then we are deciding, and my presentation is about how we analyzed 3 tools in order to make the best decision for infrastructure as code scanning. In numbers, we are like 15,000 employees, from which 5,000 are developers. We have 1.4 million happy customers, and we are like to count the payslips and invoices each month to see if we are going to beat another record. We are providing services in accounting, financial management, HRM and payroll, and e-government. And we have created in 2022 a revenue of 2,056 million euros, value for society. About cloud software, as I said, we are focusing on hosting our services in the cloud. We have had in 2022 a revenue of 1,700 million from the cloud services. We are focusing on those solutions. 90% of our R&D is spent on the cloud solutions. And we are hosting our solution on all the 3 cloud providers, public cloud providers, GCP, AWS, and Azure. Next. Now, this is the helicopter view of our Visma security program, which we are calling VSP. So in order to create business value, we need at least those 4 assets: the people, the infrastructure, the application, the solutions. And those are exposed to threats. Without threats, we would not need maybe security. So in order to reduce the risk of being attacked, we offer for the teams, companies, products, a layer of security. So for the people, we are trying to do a lot of security learning. We are doing phishing simulations. For the developers, we are offering secure code training. For the infrastructure, we have other services which I am not going to detail now, and we have solutions like GitHub, GitLab, Coverity, and those are hosted by us. And those are also tested with programs like Bug Bounty or manual application vulnerability tests. And in the end, we have also the applications, which are code-based. So if we had code vulnerabilities, we are exposed to threats. And here it's more detail how we are doing security for the applications. So if we consider them on assets and we have threats and risk, we offer those programs of data protection, self-assessment, security self-assessment, static application security test, and so on. And what you see in yellow is what we are calling shift-left security. So And in the end, you see that we have also an index. Why we need the index is because we want to see each product, what is their level of security. So if you are on a gold level, you are good in security. If you are a platinum, you are not so good. So we are trying to encourage the teams to reach a good level of security. And those results are publicly shared with the teams in the company, and we encourage them to share their index results with the clients as well. Now about the shift left security and all those assessments and services that we have. For those of you who do not know what shift left security is, for me, in my words, is the process of preventing the security vulnerabilities to arrive in production. In other words, you are positioning the security process starting at plan and design of your application and not after your code is in the production. This boosts the security of your environment and also train your developers on how to secure their code and how to write good code. And here is the well-known DevOps lifecycle. And like you can see, like for the code and build, we are using those security application security testing, security composition analysis, dynamic application security testing, and so on in the left side before we are going to release and deploy, in other words, before arriving in production. Okay, so now I'm going to pass through infrastructure as code a little bit. We have all those assessments and security programs in Visma for the code application, but we have seen that a lot of teams are using infrastructure as code to provision their services in the cloud. And we were asking if we have some tools or services to scan also this code. So we have started to see what are the security risks that the infrastructure as code is propagating to the cloud. And we have seen a lot of poor configuration of IAM policies, network misconfigurations like publicly exposed resources, secrets management as well. If you have a secret that is deleted and then you cannot recover it, it's a problem. So you have to enable some configurations in order to have your secrets safe enough. And we have seen a lot of publicly exposed resources, and maybe you have heard about a lot, not a lot, but there were incidents with S3 buckets and customer data leaked for some companies that were having those their resources in AWS. And given that we try to automate everything through infrastructure as code, we want to reduce also the risk by adopting this shift-left security approach. So after we design the infrastructure or write the code, we try to scan the code. If the infrastructure as code fits the security best practices, we are going to create those resources in the cloud. Otherwise, we are going back to write well the infrastructure code. So our goal was to find a tool that can be adopted by all our teams in our company. So not only the teams that are using hosted their services in Azure, but also for GCP and AWS. And given that all of those have their own infrastructure as code file type, we needed a tool that can code all multiple infrastructure as code file types. Oops. Okay. And we started to search for this tool. In Visma, we have an approach. We try to validate our new services using academic methods. So this was a joint research, not only in Visma, but it was led by a professor from NTNU, University in Trondheim. So we have partitioned our research in four steps. We analyzed the existing scanning tools on the market, and we have chosen 3 tools that could scan Terraform, CloudFormation, JSON, and other type of files. We spoke with the representative of each chosen tools, and then we have called development teams to volunteer so we can test the tools on real code. We have seen that there are a lot of public repositories that you can take to test those tools, but we wanted to see the real code, how we are in Visma doing infrastructure as code scanning security. After the teams provided us their code, we scanned the code using those 3 tools. We obtained the results, and we had to normalize them, explore them, and visualize them in order to interpret. And you will see on the next slide why we need to interpret them. Now, it's not on the next slide, 2 slides from here. For the tools evaluation, we have taken into account multiple metrics. So we encourage the developers to look to the ease of installation and configuration, but also documentation, reports readability, interoperability, how we integrate the tool with other CI/CD platforms. And from our department view, we have looked, besides the features, also to the security, if we can trust the tool enough, if the data is stored somewhere else than Europe. Flexibility, if we can adopt this solution fast or not. Innovation, and of course we have looked at the cost, and the cost, how much it will cost us to implement this tool and integrate it with our index application and so on, and to the license cost. How we have involved the teams, I thought this is important to say. When we send the message for the first time to involve the teams, we have not received a big applause, to say like that. It seems that the teams are afraid to participate in this kind of scanning code because they were afraid of having their vulnerabilities made public. So we have assured them that we are not going to publish the results, but we will extract the vulnerabilities, make some best practices of what we found. So we wrote blog posts, we did live demos, we wrote in Slack channels and so on. We had 22 teams who volunteered to participate, and what the teams did, that besides looking at the documentation and reports and so on, they identify false positives together with the security specialists, and they have answered some feedback forms. So, like I said, we had 22 teams. We have split the teams in function of their size, in function of the code lines they have in their project. We have mostly Azure teams that volunteer, but the AWS project were larger, and GCP as well. Results, here you have the results of the 3 tools. We have used 2 commercial tools and 1 open source tool. You can see that as the project gets bigger, so more number of lines, the number of vulnerabilities increases. What you see in red is that one tool, commercial tool, is performing differently in function of the infrastructure as code file type. So it's performing better than the open source and commercial one on CloudFormation files, but because in the 10K and 20K categories, there were more AWS projects written in CloudFormation than in the 20K, 100K, where we had more Azure projects with infrastructure as code file types written in ARM, JSON. Now, what we have found, common issues across providers. We found a lot of publicly exposed resources, so SQL servers, storages, Kubernetes API, IAM issues, and a lot of encryption problems. What I can say is that the developers are relying a lot of the security that is provided by the cloud provider. So for Azure, we had a lot of public storage accounts because by default in Azure, the storage accounts are public. And in AWS, there were a lot of unencrypted storages because by default, AWS is not offering encryption. At least this was last year. So we saw that the default configurations, if the developers let the default configuration in place, this might be prone to vulnerabilities. And for the new services, the adopter of Kubernetes, they had also misconfigurations for their services. We had no hard-coded secrets in the 22 projects. And this is because we had a lot of awareness sessions about passwords in the code. So it's like we have validated that those awareness sessions that we are holding in our company are good. Now, with all those vulnerabilities, we analyze them, we analyze the vulnerable services, and we write blog posts in order to raise the security awareness in the company. What the teams were saying about the tools, they prefer a tool that has good documentation, a good interface, and they prefer a tool that is used also for the scanning of the application code. So they did not want another tool that is scanning infrastructure code. They wanted the same tool that is used for the application code to be used also for the infrastructure code. For the experience, it was really appreciated that they did this research project together with us because they understood better their infrastructure, they learned a lot on the security side, and they were, in the end, motivated to adopt the infrastructure code scan. What we have discovered on our side was that there were projects with partially provisioned infrastructure as code. There were projects where Bash and PowerShell scripts were used to provision this infrastructure, and there were no tools that were covering this kind of scripts. Infrastructure as code is not applicable if you have the rift. So if someone else is going to modify your resources in the cloud, and this is not reflected in the code, you are uncovered. And the teams were like prioritizing more the security code and ignoring the security runtime. So we saw that infrastructure as code is good, but it's like not enough. And we thought that we need to think also for the cloud infrastructure to start at the beginning when we are planning and designing our system, that maybe threat modeling sessions are not bad to have them there as well, and also for the runtime. We need to see if at the runtime, the workload protection, the data protection is okay. And here you have an image of a cloud-native application protection that was mentioned in Gartner some months ago. So besides infrastructure as code, we saw that we need to focus also on the cloud security posture management, which is like the DAST, Dynamic Application Security Testing, where we are looking to the cloud configuration. This is for the drift, especially if you are using infrastructure as code. For the IAM configurations, the cloud work protection platform for the malware, in case you have malware on the VMs or on your storages and so on. And for data security protection platform. And here I can send that we are evaluating 2 tools right now. We have more teams than in the previous project. And for me, at least for the data protection, security protection, it was like a surprise to see that we have unencrypted data on some sensitive information. What else is that we are trying by those security issues to improve our security by design process. So what we are finding at the code level and at the runtime level, we want to use at the design level. So we are extracting all the issues, and based on the issues and the resources where we have found those issues, we will create questions that will be asked during threat modeling sessions. What we want to achieve is to extend our security program, to take into account the cloud infrastructure security, and to define also here a layer of protections, like infrastructure as code scanning, cloud workload protection platforms, and other services. And of course, we want to track the level of our teams on how well they are doing on the infrastructure side from a security point of view. What we have learned, if we are not blaming the teams that have security issues, this encourages trust and openness in the company. Involving the teams in choosing the right tool motivates them to adopt the new technologies, and discussing the findings with the teams increase the security level, the security knowledge. So in other words, by involving the teams, we train them, they become our ambassadors in the company, other teams join the program, and we have a high security coverage. In conclusion, cloud security is a shared responsibility. You should not rely only on the cloud provider. Shift left with infrastructure scope scan is one step in your defense line against threats. And by involving the teams, you can achieve more in raising the security awareness in your company. If you have questions, you can write me on Slack. And this is part from our Visma security program, this project was under the lead of Daniela Cruzes and Dr. Daniela Cruzes and Dr. Monica Iovan, and it was a joint work with my colleague Nicoleta Botoșanu. Thank you all.